A very warm welcome, everyone, to this 8th session in INTBAU's Architecture Challenge series. My name is Harriet Wenberg, and I'm Executive Director of INTBAU. The Architecture Challenge is a design competition for resilient and adaptable houses that advance, adapt, and update specific local building traditions to meet 21st century needs. After a first round of entries, we've simplified the competition brief and doubled the available prize money to encourage participants to think even more about the concept at the core of the competition, which is to engage with time-tested building traditions to determine how they can be replicated and adapted for a specific site for a low or no carbon result. And although this sounds simple, we know there are factors that make it more complicated than it sounds, with one of these factors being supply chains and the availability of the materials upon which building traditions are or were based. And our speakers today are going to help us with this. The competition deadline is the 31st of January, 2023, and the next online sessions between now and then will have a workshop format and will also serve to introduce the competition jurors and to give participants a chance to ask questions as they work up their design proposals. You can register at challenge.intbau.org to take part and to be sent full details if you haven't already done so. Just before introducing our first speaker for today's session, wanting to thank Alireza and Mina Sagarchi and Stanhope Gate Architecture, our supporters, and whose support has made the Architecture Challenge and all of these sessions possible. So today's session is on supply chains deconstructed, and our first speaker is Adam Lusby. And Adam is a senior lecturer at the University of Exeter with a focus on the regenerative circular economy and cradle-to-cradle design methods. So without anything further from me, Adam, over to you.
Thank you very much, Harriet. And I really, I want to just get straight into it here in terms of looking at the circular economy. It's an idea that many of you are probably familiar with, but I really want to start with this definition. And I've broken all the rules of PowerPoint by putting this much text on, but I'll pull some of it apart for you. And I really like this definition because it reveals the depth and the richness of the idea of the circular economy. In terms of a circular economy being an industrial economy, I think that's an important point to pull out here. But I've also pulled out waste and food, so waste equaling food in a circular economy, so that all the materials that we use and create, somehow they get back into the system and get reused. The circular economy separates two cycles, so it has a biological cycle and a technical cycle, so that materials can return safely to the biosphere, which I think is an important point. And then finally, this idea of the purer the material and the higher the quality, the more value we retain in our economy. So it is an economic question for me. It is about economics, about business, this definition. Pulling out further, this capital assets that are maintained and rebuilt, again, a very economic question about how we use our materials. But when we talk about capitals, it's important to recognize that this is not just financial capital, it's manufactured capital, human, social, and of course, natural capital. So we're rebuilding the whole system, maintaining the whole system as we go through. And then finally, this idea where we mirror nature and the activities are enhancing and optimizing the systems in which we're operating. So in terms of nature, this idea that we have something to emulate, something to mirror, and of course this comes from one of the schools of thought of the circular economy, biomimicry. And here, probably the best analogy for us is the forest, and we'll return to the forest a little bit later in this in my talk. But first, let's not forget that we're currently in a linear system of take, make, dispose. And our current idea of a supply chain reflects this. And it starts with the language. Supply is conceived as a one-way street. And if we think about a chain moving from one link to another, this is also a one-way street to waste in our current system. There's no capacity for returning value or reverse logistics. It all results in an end of pipe problem that ultimately pollutes our planet. Our linear supply chains are also limited in their visibility and their lack of feedback that leads to very poor design decisions that cascade across the system, from unrepairability, unusability, to premature obsolescence, all cascading to use more energy, more natural resources, and creating that waste. They're brittle as well, as COVID has revealed. They're so efficient. We've become so efficient in the way that we run our supply chains. There's no slack. There's no movement in the system. And so the question I have is, what would nature do? Before I jump into this, into the forest, I want to ask a question. When did you first realize everything is connected? When we jump into the forest with the tall trees, the saplings, the birds, the mammals, what we may be not aware of is that underground there's a network of mycelium that sends food, energy, and messages in every direction. It is local, resilient, and supports the health of the whole system. Now, in design and business terms, this is about creating a value network, not a supply chain. A value network that, instead of extracting, feeds value to the system, the whole ecosystem, and all its actors. The point about the forest is it's not just one tree. The healthiest tree lives in the healthiest forest. And I think this is a really important point that we must consider when we're thinking about changing from supply chains to value networks. Net zero is not enough anymore. We need to challenge how what we design can ultimately have multiple positive impacts across multiple systems. In other words, we mirror nature in activity, enhancing and optimizing the systems we depend on. Going further and really trying to emulate the forest. So returning back to the idea of a circular economy, one that takes us maybe to a lens of nature, and also challenges us to rethink about our business, not just how we design materials, but in what systems those materials sit within. This means creating value networks which supports the flow of value back and across a system. Be that a brick or access to equitable shelter, we must reimagine not just how we design buildings, but the systems they are irrevocably linked to. Thank you very much. I look forward to your questions.
Great start, Adam. Thank you very much. And giving us insight into some of the problems with linear and some of the reasons for the need for a circle. And there's human, social, and natural sources of capital. And certainly I think a hard truth for lots of us to be accepting that net zero is already not enough, when it could be said that the world, or much of the world, hasn't really come to terms even with net zero. So much to be done makes this session even more urgently important. Our second speaker, Fanos Hadjikyriakou, is a co-founder of 2050 Materials, which is a company of architects, climate experts, and software engineers building tools to empower architects and contractors to find, compare, and specify the most sustainable building products available. And Fanos will tell us more about that work now. Welcome, Fanos.
Thank you. All right. Okay. Yeah, really nice to be here and to talk to everyone. I really look forward to a discussion also, and any questions that might arise. As Harriet mentioned, basically what we do at 2050 Materials is that we are trying to bring the materials of the future to the market today, and it's a topic that I feel very strong about. We talk about a lot of targets in the future, and let's say a positive future that will keep us within climate reason. However, especially in the built environment, and especially for architects and designers, this future is something that they're already hopefully working on today. So the buildings that you are working on today and the projects you're working on today should actually be aligned with whatever we're expecting to have in 2050. And what we try to do is essentially open up the space so that you can do that. Now, yeah, to start, I guess, a similar statement is that the design, any sort of design, in my opinion, without sustainable materials, and when I say sustainable materials, that doesn't just look at carbon, but it looks at all kinds of data around materials. Any design that doesn't include the consideration of sustainability around the material the materiality of the building or the project, in my view, is outdated. And there's a couple of reasons for that. The first is that regulators are very much moving towards a direction where they're demanding low carbon regulation and low carbon buildings. And I think this competition is a great example of that, even though it's not regulated. This is something we are seeing from our work being asked for from clients all the time. Now, the second issue is that which is not so much an issue, but basically there's a lot of product innovations that are around there that allow architects to design and then eventually build low carbon and sustainable buildings and add sustainable materials in their projects. And then finally, what falls under the umbrella of green design, in my view, again, is just getting started. So in a lot of the conversations that we have with either designers or architectural offices, from small ones to all the way to really global ones, it seems like most clients are at the very least starting conversation around sustainability now, and in a lot of cases setting very specific targets that need to be met. Now, unfortunately, as I'm sure you already know, sustainability is not an easy topic to tackle. There's 1,000,001 questions probably that we can ask when we talk about sustainable materials, and the information, as far as we've seen, is sort of spread all around the internet. So this is just an example of some questions on Quora, this website where people can just ask any question around sustainable materials. Now, in order to demonstrate that, and maybe a lot of people on this call have already gone through this process, but we went through this exercise of thinking, okay, what if I want to assess the sustainability of a list of 5 different products? Let's just assume I'm trying to understand the sustainability of 5 different bricks. So there's a few steps. The first thing is you have to look for any sort of environmental certifications for each product. And you also have to access usually the manufacturer's website for that information. Now, once you get access to often certifications like EPDs, so environmental product declarations, or any other certification from ISO certifications to health product declarations to anything else the manufacturer might have created, you start collecting some of that information. At the same time, through the website, you usually send a lot of requests, and the requests can sometimes be linked to things like the cost of the product or any additional information. But often, unfortunately, a lot of these assessments, like an environmental product declaration, even though it might exist, it's not always easily accessible. So often there's a lot of back and forth with manufacturers to get that information. Then once you do that, you compile data, hopefully, if you understand all of the data, into an Excel sheet probably, and into a report that you can discuss with your client. And then you also have to deal with more emails in your mailbox from manufacturers trying to send you the information that you're asking for, with the end goal of ideally having an indication of performance of each product in different categories that define sustainability. So I'm really just putting some of them here. So you could look at carbon footprints, of course, the circularity metric, whether there's any waste that will be created either to manufacture the product or at the end of life, if there's any health implications related to the materiality of the building, if there's any social considerations, and of course, if it fits your budget. Now, what we do is basically we understood the pain points of this process, and we centralize a lot of data around the sustainability of construction products that are out there already on a platform that's free to use by designers and architects. And we allow these kind of assessments to be done in a much faster and more efficient way. The way it works is you can access the platform freely, as I said, and you can find products depending on whatever classification you decide to look for. And you would find things like the carbon footprint of the product, the amount of fresh water that's used, whether there's any recycled materials, whether there's any social considerations that you need to take into account, and often the cost as well. Now, what we really aim for is to get the manufacturers to become more transparent. And that's because we think that a sector that is actually net zero and actually goes to zero emissions and zero impact towards the planet needs to have collaboration. And part of that collaboration comes from the people and the companies who create all of these materials. So a lot of what we do is we empower the manufacturers that are already creating a lot of data or have a lot of data on their products to put it out there in a format that is easily accessible and easily understandable by the designers. And the end goal behind all this is, if you have the question of what is the most sustainable brick that I can find in my area, you could sort of do it by running a very quick search of masonry or bricks on our platform, filter according to the manufacturing region, so something that's close to your project site, and then you can compare products and generate an assessment that includes hopefully a holistic list of metrics around the sustainability of that type of product. Now, I want to finish a little bit my talk on a positive note. I think there's a lot of negativity that's being heard around the construction sector, and especially architects are feeling the pressure because they know their work is contributing to a big extent to climate change. I think personally that architecture can really be a driving force to reach climate targets, and I think competitions like the one that's happening by INTBAU are great because it shows that net zero and low impact on the planet buildings are actually possible. The screenshot here is just from an example of a way that we've helped an office deliver a building in Berlin that's actually aligned with the 2030 target. So not even today's targets, but something that actually it can achieve something that we're aiming to achieve in the future. Yeah, I think that's all I wanted to say. I would really encourage anyone who is working either on this project or other projects to just go to our platform and use it freely. It's app.2050materials.com. Yeah, and I look forward to any questions. Thanks a lot.
Thank you, Thanos, very much. That's great. And 2050 materials, meaning there really is no excuse not to specify in a genuinely sustainable way now for people. And I say genuinely just because of the overuse. I think we all know of the adjective sustainable, and you showed a number of the examples of it being used all over in discussions already. So I hope there'll be questions for Thanos when we come to that section on how to use 2050 materials or how the platform was developed or otherwise. We're going to turn now to our third speaker, EV4, and EV works with Biome, which is a biotechnology company that seeks to revolutionize construction through nature-inspired innovation by using mycelium, on which more from Evie, and also food waste. Evie, over to you.
Hello, everyone. Thank you for the introduction, Harriet. So my name's EV4 and I'm the engagement lead here at Biome. So in this talk, I'm just going to tell you a little bit more about Biome, our nature-inspired approach to developing innovative materials for the construction industry. So Biome's a research and development company that allows nature to lead innovation to revolutionize the construction industry and to create a more healthy and sustainable built environment. So our company is made up of a mixed team of engineers, biotechnologists, mycologists, material scientists, chemists, and business and social innovators from all around the world. So at the core of our practices and material development processes is something that Adam mentioned, biomimetics. So biomimetics involves taking inspiration from nature when designing and manufacturing materials. So we look at how biological processes have evolved to become so perfect to solve problems in nature, and then we apply this to our problem-solving technologies. So our philosophy is nature-inspired, and we reflect this not only in our products, but actually in everything we do at Biome. So one organism that's not only inspired us, but is also an organism that we employ is fungi. So we work more specifically with mycelium, which is the vegetative part of the fungus. It's the root structure that lives beneath the soil. So unlike the mushroom, which is the fruiting body and the part we eat, something you might recognize, mycelium is the network of tiny filaments that live beneath the soil. So mycelium can be found everywhere in the world, and it acts as a connective web that helps plants share nutrients and communicate with each other. So at Biome, we work with mycelium's ability to actually grow and consume organic matter. We've collected a library of over 300 strains of mycelium, and we've even got strains that can consume plastic. So we tend to grow the fungi on agricultural waste. So the substrate, which in this photo you can see is hemp stalks, not only acts as a food source for the mycelium, but it also acts as a structural frame for mycelium to grow around. The growing process is very low energy and it takes around 2 weeks. So as it grows, mycelium forms small air pockets, which make the material a really great sound and heat insulator. And for this reason, we've developed the technology into an insulation panel. So mycelium insulation panels outperform conventional products, and initial tests have shown a thermal conductivity value, which is actually very competitive with market alternatives. So we're just in the final stages of getting this product accredited by BBA, the British Board of Agreement, at which point the product will then become commercially available and we will begin the full scaled up production of mycelium insulation in the UK. So thanks to mycelium composite materials also having acoustic insulating properties, we also developed an acoustic panel, Edge. So this allowed us to bring the natural biophilic elements of the product into interior spaces rather than concealed behind walls and wall cavities. So not only are the panels really visually interesting, but they also have positive effects on emotional and psychological well-being. So the other technology we've developed is ORB. This stands for Organic Refuse Biocompound. So our ORB technology is based off a unique plant-based binder which we've developed. And this is a completely natural binder that glues together waste substrates. So the substrates that we tend to use are significant agricultural byproducts and food waste, and they are all sourced locally. So we've worked with orange peel from local juicers, coffee chaff from coffee roasters, sugarcane, cardboard, as well as other substrates. And we usually use problematic waste streams that often don't have end-of-life solutions in place. Our ORB technology gives birth to a whole range of innovative products with really unique properties that vary depending on the substrate that we put into the material. And ORB materials can be used for dry cladding, interior architecture, as well as products and furniture design. And we're also working towards developing an ORB construction board to replace the likes of MDF and plywood, that sort of thing, in the construction industry. We've also designed a range of lampshades. These are obscures, which are made from orange peel and coffee chaff. And these also have that element of biophilic design. So they're created and designed to allow the natural forces of gravity to actually lead the design of the lampshade. Obscure has kind of helped us bring bio-based materials into the makeup of buildings due to the lack of accreditation needed, but it also allows companies to decarbonize their fit-out projects. So these are obscures hung in restaurants and cafes. So we've got them in Gales and Henley, and also in a restaurant in Mayfair in Apron City. And they tell really nice waste to product circularity story, especially in these establishments that serve food. We're also currently developing a tile which is made from 100% orange peel. So this is our new ORB technology that doesn't use a binder, but actually uses the intrinsic binding properties of the waste to glue the matter together. And this is a new product which is currently still in development, but we will hopefully be launching within the next year. So like mycelium, ORB materials are completely natural and biodegradable. At the end of their lives, both ORB and mycelium can be cold composted and fed back into our manufacturing processes. So by diverting the waste away from landfill, we're actually halting the degradation process, which releases CO2 into the atmosphere, and instead we're trapping the carbon stored in that organic waste into a material. So our products and technologies allow companies that we're working with to deliver on their carbon targets and achieve their sustainable development goals. We also help companies decarbonize through our services. So as an R&D team with many years of experience using these technologies and developing innovative materials, we now can offer up our services to help companies transform their waste into novel materials using biotechnology. So one of our services is climate positive resource management, and this looks into different waste streams and tests the feasibility of incorporating these waste streams into either orb or mycelium materials. So this was a project that we did with GS8 on Orford Road in North London, and we actually looked at the waste streams from a housing development project. So we identified a few different waste streams, but also one of them was the excavated soil from the site, and this was quite a problematic waste stream. So we tested the feasibility of incorporating it into our materials. We developed a soil orb which had really interesting properties, including being a really strong material. So thanks to the material properties, we were able to develop a range of interior design products, which were then fed back into the homes that were built on this site. So we made lampshades, some shelving and a headboard. And this just told a really nice circular story of bringing the waste from the construction site right back into the homes that were built in the form of interior design products. So thank you for listening, and I look forward to questions at the end.
Thanks, Evie, very much. A really fascinating introduction, I'm sure, for many of us to mycelium and also to some of the other products under development for Biome. Any design submission to the Architecture Challenge that also wants to get into the interior fit out is most welcome to do that. So there'll be lots of the research and work that Biome are doing that some might like to draw from. And also with your second mention of biomimetics and biomimicry for the session today, just wanting again to make it clear that that's again sort of ties into this core concept to the Architecture Challenge, which is again the learning from existing and evolving and time-tested building traditions that often have at their heart this inherent balance between people and nature. So a challenge to some of you entering the challenge to think about how building traditions would adapt to incorporate brand new materials like mycelium. So hope to see some thinking on those, and thanks again, Evie. Our fourth and final speaker today, George Santos Silva, is an architect with an MSc in Sustainable Urban Development, and he's going to speak to us today both from and about Pico, which is an island in the Portuguese Azores, and which was also the base for INTBAU's July Rafael Manzano Summer School. And George is going to talk us through Pico as a case study in the necessity of using local materials and in traditional building techniques that have developed within the island's 275 square miles. George, welcome, and over to you.
Well, thank you, Harriet. Hello, everyone. So this presentation was part of this year's INTBAU Traditional Architectural Summer School held in Pico. And by the time the students reached this presentation, they already had some historical and geological understanding of Pico Island. So the Azores Islands were discovered in 1427. They are in the middle of the North Atlantic, and Pico is the youngest island of them all, with 300,000 years old. And this will matter to the study of the traditional architecture. The island itself, it's 45 kilometers long and 20 kilometers wide. It has several volcanoes. You have a big volcano. Let me see if this can work now. Okay. There's a big volcano here, 2,000 meters high, and then several thousand volcanoes, 100 volcanoes in this coastline. You have to have a sense of topography. You have the coastline on this black line. You have this 200 meters high line and the 400 meters high line there. So you see that you have areas in the islands and like this, that here in this area you have a very dense and a very dramatic topography, and on this newer part of the island, more recent part of the island, geological speaking, you have a more soft platform on topography. The first thing that we discussed about in traditional architecture is the feeling of living in these traditional structures. So this is a sentence from Raul Brandão, a journalist in 1926, who states that this feeling of darkness and this feeling of great grief and great desolation in everything that life in Pico Island was about. One thing that I want to share with you is that unlike all of the other traditional architectures we see around the world, Pico traditional architecture is not based on the heritage of so many generations and millenniums of adapting some architecture to a traditional, to a specific climate or to specific materials that you can find in the area. It's a tradition that has a day one through the movements of the discoveries, the Portuguese discoveries. And since that day one, the builders quickly adapt their traditional heritage from their mainland Portugal or other places in Europe. And when they arrived to the islands, they had to quickly adapt to the materials that they had at hand because the supply chains were very limited at the time. So how do you settle in the new land? So you already know that the island is a volcanic island, so you only have basalt stone and wood. You don't have any rainwater, not rainwater, sorry. You don't have any rivers or any water basins because the island is so young that it cannot retain water. So you only have water streams. In that in mind, the first settlers were looking for these areas here where you have kind of a natural bay and you have some water streams, rainwater streams coming down that you can use. So the first structures were located on that areas, and the first structures were the canadas, the perpendicular to the coast. Then, as the society developed here, they also had coastal settlements and parallel to the coast more recently. The canadas were then in a way perpendicular to the coast, where they concentrate all the constructions to liberate the maximum area of soil for agriculture. These canadas again were done mainly where you have big rainwater streams, and try to go to that areas where the topography is not that aggressive, that the soil is not retained on the ground and the heavy rainfalls. The second coastal settlements, the second way of settlement is coastal settlement. So, unlike the canadas, where the persons who take care of the land were the owners of the land, and we have very small properties. Here we have very big vineyard properties through a new economy, which was the wine economy in the island. And these settlements worked as industrial complexes. So they were always backed with the great fields of vineyards. The workers were not the owners of the land anymore. They are simply workers working for someone else. And these settlements work like industrial complex. They gather the vineyards, the wine, the grapes behind them. They will transform them into wine, and then they ship them out to the other islands and to the rest of the world. This created these very strong cultural landscapes where all the flat areas of the island were occupied with this mesh of small volcanic walls, about 1 meter high. And these walls, as you can see here, will allow them to protect the grapes from the salty winds from the sea, and also to capture the warmth of the sun and to have the grapes mature. In terms of the traditional architecture of Pico, the Pico architecture is a dry stone architecture. you have to see that being in a volcanic island, you don't have anything apart from basalt stone and wood. You don't have mortars, you don't have anything to isolate the constructions. And although there was already a chain of supply in the islands due to the movements of the ships in the Portuguese discoveries, the only accessible or the fundamental elements that materials that were shipped into the island were roof tiles and the small glasses for the windows. Therefore, and this Al-Sayad sentence is very relevant to Pico architecture. This tradition is a product of the absence of choice. It's the lack of materials, the lack of the economic limitations, the lack of availability of materials that define the specific way to build. And builders from that time on, of course, they bring with them cultural heritage with them, a traditional building heritage. But the moment they arrive in the islands, the spirit of the place, so to speak, overcome their knowledge and the spirit of the time on how do you build. And there are some lessons on this adaptation and trying to do the best you can with the materials that you have at hand. So the quality of the stone put a limit to the height of the constructions. The quality of the wood puts also a limit on the width of the construction, or the span that the roof can cover. And the technique, the seismic technique of the time, also placed the limit on the size of each volumes. The lack of resources is very obvious when you study a ruin. So their focus was to maximize the use of the resources by minimizing the stones that they need to cut very well in order to have a stable construction. So you have here a well-cut stone that makes the corner. And then when you use the same stone to define the window. So you see that here, you see that there, and you see that over here also. That means that your facade composition is defined by the lack of resources that you have, that makes you use each stone that you cut to several uses. Also the height, so here would be something about 190 centimeters. And you can see that in order to save resources, you use the stone that you need to cut very well to support the beam of the door. Use the same stone to place the tiles, the roof. As a consequence, the houses are very short, not very high, very small, but it's a direct consequence of the lack of resources that you have. Each of these stones are very noble. They have names. A verga, the umbreira. You see that even though you have this restraint, you have always a concern about symmetry. That you use the stones with the same name in symmetry with the window or with the door. This also has a structural element to it to resist the seismic activities more. You have harmonic and balanced construction. And you can start to know how to read these constructions and define and have an idea of the status or the social status of the builder or of the family that lived there. So in comparison, you have here one very good line of well-cut stones to support the roof. And if you see on the last slide, you only have one well-cut stone. So these stones are smaller stones, just pick up from the ground, and you have obviously a family with less resources than this one. This is also seen in the corners of the building. These are the materials that use. These materials were imported, so this part of the supply chains that were brought in by boat because there is no iron on the island. Again, you need to adapt to this because you cannot just bring so many materials. It's a very expensive trip to bring materials and tools. So the builders at that time, they adapt their techniques and start to create locks, wooden locks and wooden windows that do not require the iron elements or mechanisms to function. So this is a very fast forward introduction to Pico architecture. And I think I can stop the presentation. Thank you, and looking forward for questions.
Thank you, George, very much. No, that was a hugely interesting look at the architecture of Pico. I'm sure would have been unfamiliar to many on here. And also just that reminder that building traditions can be, and so often are, the product of an absence of choice. And I think we, especially in very wasteful parts of the world, globalization having allowed many of us to forget that really the whole planet is like a Pico, is limited in terms of what there is to use and how we must use it sort of responsibly to build what we need. I'm going to hand now to Juliet Butler, INTBAU's program manager, who's going to moderate questions. We've got about 15 minutes for questions and look forward to hearing those and answers. Jules, over to you.
Thanks, Harriet. I would love to see all speakers back on screen, please, if you guys want to turn your cameras back on. Thank you all. Just looking at the Q&A, just trying to see if Jeremy would like to ask his own question, or I can certainly ask it for him. It looks like potentially I will be asking this. So first question we've got is for Panos. Jeremy is interested in how the metadata for 2050 materials is generated. For many material innovators, the cost of EPDs and other certificates is prohibitive until scale is reached. And he's also saying that there is a cycle of failing to reach scale because of a lack of certification to give the market confidence. So how can we get around this? It's a big question, but Panos, do you have any?
Yeah, that's a really good question. Thanks, Jeremy. I mean, I guess to answer the first part of the question, a lot of the data that we have do come from EPDs and other certifications, but we of course realize that, you know, that's not a clear picture of the available materials and products on the market. And I think the point you raise around the price, the prohibitive prices of getting an EPD, for example, is clearly an issue we want to tackle. One thing we are doing in that direction is that we are providing essentially an easy or a fast EPD estimator, if you like, for new materials if we have enough information on them. So what you would see on the platform for products that do not have EPDs is you would usually see a carbon footprint that is estimated based on their main material, and we are expanding that to essentially include more data. And what we want to do is, you know, we want to collect all of the information that exists today on products and see if we can use that to fill in data gaps essentially in the sector. In terms of confidence in the lack of a certification from, let's say, a third party verified body that people trust, I think that's still going to be an issue probably for a while. In my opinion, as products which are more sustainable expand to the market and people start, you know, having trust, not only basing their trust not only on an EPD, but also on previous use cases of materials, and also starting to understand, you know, when is a product applicable. I think that's probably one solution to the issue. But yeah, I believe that the cost of these kind of certifications will inevitably drop as well as it becomes a let's say a requirement for the market to have them.
Thank you. And another thing, of course, that helps with credibility is precedence. So working from the built form and working that way, which we hope the design competition will help to achieve with the final entries too. Thank you, Thanos. Moving to Evie, I've got a question from Victoria here, and Victoria is very kindly helping run this session with me, but she's actually a participant in the challenge and has submitted a design proposal. So Victoria, do you want to ask your question to Evie?
So Evie, I was wondering about mycelium and orb, and those are really, really interesting new materials. And so that's why I was wondering if you could tell us a bit more about what does the mycelium fungus survive on? So what's the material? And the second about that first one about mycelium is it also, you mentioned it's suitable for sound insulation, but is it also suitable for thermal insulation?
Yeah, so thank you for your question, Victoria. So we work with mycelium, the organism, and it basically grows on agricultural waste. So we use the waste as a food source, and the mycelium basically grows in and around using the waste as food, but also as a structure. So it makes a compact composite foam, something like this, which you can see behind me, a mycelium board. And the way it grows basically forms these small little air pockets inside the material. And that's what gives it the amazing thermal conductivity values that we're achieving, and also the acoustic properties that we're getting. So the goal is to develop a commodity product, an insulation panel, which we're now producing in our site in London at the moment, but we're hoping to scale up once we've got that full accreditation VBA. So eventually we'll basically be vertically farming panels for insulation to replace the alternatives that are much more harmful out there on the market.
Excellent.
And just as an answer to your second part, the acoustic panels, that's a product that we've also developed, but it's also given us the ability to basically bring it into the interiors of a build-up and for interior design purposes, as well as to get people talking about bio-based materials kind of in the build-up to the launch of the insulation panels.
Excellent. And that just links, sorry, I said I have a second question, which is about the glue. So I'm going to ask that later, but I had new questions as you were saying that. So is this mycelium, how does it perform with water or rodents? You know, so some insulation, they are sensitive to kind of rodents eating them, or water, or also can you walk on it? So how's the performance there?
Yeah, so it's quite a structurally sound material, and we've got testing that we carry out in-house as well as out of house. So we've got all the data on the material properties in terms of strength and flexibility and thermal conductivity, but also in terms of water and rodents. So it's got some bioresistant properties, and we're looking also towards nature to be inspired by some of the ways that we can increase that bioresistance. And the material itself has got really interesting skin. It's very breathable, and it's also self-wicking. So if it were to absorb water, it can easily release it as well over time. We do recommend it to be used in indoor applications rather than externally, because if exposed to the elements as a natural product, it will eventually biodegrade. So that's how we kind of recommend the application of insulation.
And you can walk on it? Could you put it on the floor?
Yeah, you can put it on the floor, you can walk on it. If you were to use it as an actual flooring component, you would need structural elements in between as well, because you might crash through it.
Yeah, interesting. So that's really, really interesting. Thanks. And the second question I had about the orb glue that you mentioned, I was wondering what is actually the binder material? So what is the orb material?
So it's a completely natural resin. It's a plant-based resin. I can't disclose the secret recipe to you right now, but I can tell you that it's completely bio-based and biodegradable at end of life. So we mix this together with other components. But yeah, it's 100% a natural binder.
Mm-hmm. Thank you. Thank you very much.
Thanks, Victoria. I have a question here for George. So it's fascinating to see your presentation. And of course, it's the recent summer school, which is kind of the reason behind us having found you and had you on this session, really. So I think what I wanted to ask was, because of the architecture of limited means that you've described and talked about, what did the students take away with them? Were you able to sort of see a change in their perspective, I guess, because of the abundance of choice that designers have? That's often the problem or part of the issue these days.
Yes, I believe it has some impact. But the aim of the summer school in the end was it was a two-step summer school. So the first part, we need to understand the context we are in, we need to operate, so that in the second week we can have a proposal for an urban redesign of an area. And it's the idea is that you cannot have multinational team create a proposal for a specific site, especially in Pico, where the cultural landscape is still very strong, without having a full understanding what's the context, how that cultural landscape and heritage was created, and how that relates to the local communities and all that. So in the end, of course, it's a 2-week summer school, and it's hard to go very deep into these considerations. And it was clear to everyone that when we go to design into a different area, we bring with us a lot of cultural habits. So you could see the American students had one kind of approach, the European students had another kind of approach, and in the end you have to mix everything together, but also with the local context. So it's not a perfect reply for the context, but it's very illustrative how we all carry our cultural baggage with us when we design in other places.
Thanks. Absolutely. And that brings me to ask another question, and then we'll move to a question from Bradley, which is, I think, specifically for Evie again. But in future, with changing climate and conditions, perhaps meaning that material choice is going to be dictated by what's available. So perhaps from the supply chains changing in terms of, if we use timber as an example, we've had in previous sessions, I know, Jez, Ralph speaking about the forester having to decide and dictate what is available and what architects can design with when it comes to specific species of tree. Do we think that's going to affect and shift things considerably? I mean, this is quite a broad question, looking at supply chains and global supply chains in a broad way, but perhaps if you all had an opinion, we could go around. And Adam, I know we've not heard from you, so do you have any thoughts when it comes to that?
Yeah, thank you, Jules. Yeah, I think this issue about I suppose almost in some ways the circular economy, or the way that we might have to design, is going to mean that we actually let go of some traditions, or we challenge our traditions. I think that's going to be some of the challenges here about certain areas. Obviously their climate will change, and they'll have to change their approach to the way that they live, and therefore the materials they use. I think the circular economy suggests that materials are local. So Pico Island is a great example of, using what's local. And it's sort of, I suppose it becomes local because if you're going to reuse material, you're not going to ship it halfway across the world, or, you're not going to keep on this process of, moving a lot of material around the world. So you sort of think about material banks and buildings as material banks and things like that, where we use the materials again. So we wouldn't, I think we'd see maybe challenge quite a lot of the fact of new. So a lot of, obviously, designers think, oh, I must need new materials, but actually the reclaiming of materials and how we use it, which Evie showed in her demonstration. And I think then the other question is about biomaterials, and how we, start to think about actually, planting and managing ecosystem services so that we have future materials that can be returned to the local biosphere. So I think that's also so on the cards. But that again is primarily going to be local because of energy use and cost, I would suggest. Hopefully that made sense.
Absolutely, yeah. Local actors being key. Panos, do you have anything to add to that in terms of ways in which the process is going to perhaps be dictated by external factors rather than the abundance of choice? Yeah.
I think that's, the simplest way to look at this is just regional availability is one thing to start from. But generally speaking, what we are seeing in terms of what clients are asking for, maybe less so in large commercial, like for commercial buildings in central London, but let's say when people are really focusing on delivering a sustainable project, they're really trying to think of not just sustainability as a generic description that applies everywhere, but really something that is applicable regionally and has considerations of what needs to be done regionally. So I guess from my perspective, I think the picture is positive in terms of data. So there's data to answer different kinds of things, but it's important to really work with clients or whoever is setting the targets on the project to really find them, specific to where we're building, what the restrictions are, and all of those things.
Great. Yeah, absolutely. Evie or George, do you have anything to add? And then we'll move to our last question because it's now nearly the end of the session. But
I just wanted to add, that's a really interesting question. And I think with the changing climate, agricultural landscapes and crops will change. And from a biome perspective, that is something which we welcome, and we've actually designed for that change through our technologies, is applying the technologies to a whole variety of different waste streams, whatever they may be and wherever they may be, so that they can be used to develop materials for buildings, whether it's a sugarcane plantation or a coffee plantation or wherever you might be in the world, and also using those traditional, maybe skilled people and the traditional workforce to work with the technologies in a new way, transfer their skills towards those new changing crops and new technologies and materials.
Yeah, I think that's something that past speakers looking at hempcrete have mentioned as well. The substrate or the aggregate can change depending on local crops. Yeah, absolutely. Versatility is great. Right, well, that brings me to the end of the session. I'd just like to thank all speakers for their presentations. And I think, we've got one more question. Okay, we'll keep running, but I appreciate that some people perhaps have to drop off. Very specific one about the cost projection per cubic foot of insulation, Evie.
Yeah, this is quite a quick one probably.
Okay.
So we're looking, when we launch the material out of our current production space in Southeast London at the moment, we're looking at about £30 per square metre with a thickness of 75 mil is what we've got at the moment. But as we scale up, we'll bring that price down and be matching, hopefully, our competitors in the industry, so that people won't need to make their material decisions based on price and instead can do it based on sustainability factors.
Thanks, wonderful. Okay, well, that's all from me with the questions, but our speakers, I'm sure, would be willing to answer further questions. If you have any ones that come to you later on, please email me. My contact details are on the INTBAU website, and I'll also put them in the chat here. So just pass over to my colleague Harriet as well to give her thanks.
Great, thank you, Jules. Well, first, thanks to Jules and to Victoria for running the session, making it all work. Thank you both very, very much. And great questions and answers. And last thanks and biggest thanks to Adam, to Panos, to Evie, and to George. Thank you very much for being with us today. And once this session's available and up on our YouTube channel, encourage anyone to watch again and also to share it with your networks, and encourage anyone you know who might be interested to get involved in the Architecture Challenge and think of putting in a design submission before the 31st of January. So thanks again to everyone. Really interesting hour.
Thanks, everyone. Take care.
Thanks, everyone.